This is section 1.1, part B, on the commutative, associative, and distributive laws. First we have the equation 3 plus 7 equals 7 plus 3, and 3 times 7 equals 7 plus 3. We know that this is true because 3 plus 7 is 10, and 7 plus 3 is also 10. 3 times 7 is 21, and 7 times 3 is also 21. This suggests that A plus B is the same thing as B plus A, and A times B is the same thing as B times A. These laws mean that order doesn't matter as long as you only have addition or multiplication in a problem. You can switch the order in addition, or you can switch the order in multiplication. In example 8, we're going to use the commutative law to rewrite the expression. This expression, 5 plus x, is the same thing as x plus 5. And x times 2 is the same thing as 2 times x. Now, it's important to rewrite these in the way that I have just written them because both of these are now considered to be in standard order. We'll get to that a little more after the box below. First, a term is a constant, a variable, or a product of a constant or more than one variables. So, for example, 2x, like this right here, is a term. In the other expression, this actually has two terms, so x and 5 are separate terms. And you can have other terms that have more than one variable. You could see, say, xy as a term, or you could say something like 1/3 x squared is all a term. Expressions contain some constant terms, some variable terms, and an expression may have more than one term separated by an addition or subtraction. Okay? What this bullet says, though, is that when an expression contains both a constant term or a variable term, the variable terms are usually written to the left. So that's this one right here. The variable term is to the left of the constant term. However, in a single term, where there's just one term, there is a coefficient. A coefficient is a number that's multiplied by a variable, and the coefficient is to the left. And the difference between what we're talking about in this box, this is something about when there are two terms. If there are two terms, so two or more terms, you will see the variables on the left-hand side. In a single term, the coefficient is the numeric multiplier of the variable that's to the left of the variable. All right, so we want to, in example 9, rewrite this so that the variable term is on the left. So we want to recognize that the 7 here is actually positive 7, and the minus 3x makes the 3x negative. So when I reorder this, the 3 has to stay negative. So it's going to be negative 3x plus 7. That's actually now in the standard order. The term with the variable is to the left of the numeric term. All right, we've got another law down here. The equations 3 plus 2 plus 5 and 3 plus 2 plus 5 are the same. We can just check that real fast. 3 plus 2 is 5 plus 5. That would be 10. That's the same thing as 3 plus 2 plus 5 is 7. And again, if you add that, you get 10. Okay. You can verify the multiplicative one on your own. This suggests the associative law, being A plus B plus C, is the same as A plus the group B plus C. The group A times B times C is the same thing as the group A times the group B times C. These laws mean that order, or grouping, grouping, order was the first law, means that grouping, I've not changed the order. A plus B plus C, A, B, and C are all in the same order. The grouping, where the parentheses are, has changed. Grouping doesn't matter if you just have addition or if you just have multiplication in your problem. Grab the next page. In example 10, I want to use the associative property to rewrite each of these into another form. So change the grouping. So if I change my grouping here, it's going to write this as W plus 4 plus 6. And then I know that I can do 4 plus 6, so I'm going to end up with W plus 4 plus 6 is 10. Okay. Oftentimes, whenever we're simplifying something like this, we're just going to jump down to the w plus 10. But the reason that we're allowed to do that, to add the 4 plus 6, is because of the associative law. In part B, if I regrouped these, that's all multiplication, so it would look like 8 times 4 times x. And 8 times 4 is 32, so it would simplify to 32x. Once again, usually I would just jump right to that multiplication. The reason I'm allowed to do this, though, is the associative property. In example 11, I want to rearrange these terms so that the numbers can be added. So the first thing to do is to use the commutative law to reorder, to put the x term first. So I'm going to write this as negative 5x plus 7 plus 3 minus 9. Now, if there are no parentheses currently shown, they're implicit around the first two terms. But since I can't add those terms, one has a variable, one doesn't, I need to use the associative law to regroup this so that I can add the numbers up. Okay, so that's going to be negative 5x. Let's see, if I add these, 7 plus 3 is 10, minus 9 is going to be plus 1. Okay. Once again, the associative law is a law that usually gets skipped. We don't usually write the parentheses in there. We just do it because we understand that I can regroup these so I can add those numbers together. The following law, the last law here, is a little more complicated because it involves both addition and multiplication at the same time. So we're going to check this law here. It says that 3 times 2 plus 4 is the same thing as 3 times 2 plus 3 times 4. So there are two ways of getting the same value here. The first one is to use the parentheses first. Order of operations says you do what's inside the parentheses first. So 2 plus 4 is 6. And if you do 3 times 6, you get 18. Or if you do 3 times 2, 3 times 2 is 6. Plus 3 times 4, 3 times 4 is 12. And you add that, you also get 18. So you can see in one numeric example anyway, it's true. That suggests the following law. A times B plus C is the same thing as A times B plus A times C. Okay. The distributive law gives us a way for getting around parentheses if there's a multiplication and an addition or subtraction. So it means that we can multiply the term on the outside by both parts of the sum. Now, if it was all numbers, like the example above, there's no way we want to do that. We would just want to follow order of operations like normal. However, if there are variables inside the parenthesis, that's when we can't follow order of operations, and we need something that's going to help us still be able to figure it out and still have a correct operation. Okay. So I can't do x plus 3, but I can use the distributive law and say this is the same thing as 2 times x and 2 times 3. So 2 times x plus, I know 2 times 3 is going to give me 6. It's going to allow me to simplify that. Okay, part B. I've got 2x. I'll multiply that by 4 and 8 by 4. That gives me 4 times 2x is 8x. And 4 times 8 is 32, so I'll have minus 32. We're just going to look at the distributive property a few more times in example 13. So we have 6 times 5t, that's 30t. And 6 times negative 3 will be minus 18. Part B, same thing. The distributive property is going to come from the right-hand side instead of the left, but it's still just a multiplication across the sum. So I'm going to have x times 2 is 2x, minus x times 9 is 18. Doesn't matter if it's on the left or the right. It's more traditional. You often see it on the left, but it can also occur occasionally on the right. 2 more here. Part C, I have a negative 4 to distribute. So we're going to make sure we get our signs correct here. Negative 4 times 7 is negative 28. Negative 4 times negative x is going to be a positive 4x. And lastly, before I circle this one, I know that my variable term should be to the left of my constant term, so I'm going to reorder this as 4x minus 28. And the last one. This has 3 terms on the inside. I'm going to take that negative 3 times all 3 of the terms. The number of terms on the inside doesn't matter as long as maybe instead of both right here, we can mention all terms. Get multiplied by that number. So I've got negative 3 times 2, going to give me negative 6p. negative 3 and a negative 4 make that a positive 12t. And last, a negative and a positive to make the negative 18. All right, let's flip our page. I think we have come to the end of part B.